Hey, this is Physics 2211 Lab 4 Oscillations by Karthik Chilakapati. So, our introduction, the purpose of this lab is to analyze the motion of a spring and mass in an oscillation. And fundamental physics principles we use are kinetic energy, 1 half mv squared, gravitational potential energy, mgh, and spring potential energy, 1 half kx squared. This is to analyze the motion as we get the position and velocity of the spring and mass. And then we also use our velocity update and position update to actually get these position and velocity values. The results are that the model data was about zero point 0.5 seconds ahead of the experiment data in the x direction, and the model data had a greater amplitude than the experiment data in the y direction. Our initial conditions given to us in the video were 0.402 kilograms for the ball's mass, 6.83 newtons per meter for the spring constant, and 0.123 meters for the length of the spring in a relaxed state. The initial position of the mass was around negative 0.0102 meters in the x direction and negative 0.710 meters in the y direction. We decided our system would be the spring, mass, and earth and have no surroundings. So this is the observable motion of our oscillation given to us in this video. And we set our origin at this fixed point up here, and we have our mass all the way down here. And these are our x and y data position data for the mass. Computational data, we basically had to alter the starter code and add in the different energies such as kinetic energy of 1 half mv squared, gravitational potential, and spring potential, and then add them all together to get our overall total energy of the system. And we also had our initial kinetic, gravitational, and spring energies here, and then altered them throughout the motion of the mass. And then we get this graph generated of the different changes of each of the type of energies. So comparisons between the model and experiment in both x and y directions. Here we have our x position versus time. The blue line is the code that we generated, and the red is the experiment. We can see that the experiment is a little behind compared to the model, but having the same amplitude. And in y position, we can see that the model had more amplitude than our actual experiment that ran through. Sources of error that the origin probably wasn't at the exact center of the fixed point where the string was hanging off of. And also the tracker mostly didn't get the exact position of the center of the mass, which could have caused discrepancies in the position data. And our what does it mean question number one asks, is the energy principle justified? It is justified because at any point along our x-axis, so let's say if we choose this point, if we add up all the values of the points above and below, we get 0. And that's what this orange line represents, the change in energy. And for the whole graph, we can see that it's always 0. And then the second, what does it mean question, we had to estimate the period of oscillations in both the x and y directions. So to calculate that, we basically went from one peak to another to see how long this distance would take in our experiment. And for our x direction, we found that this time difference was about 1.898 seconds. And for the y direction, it was about 1.520 seconds. And that is it. Thank you.